Okay, so today we are going to introduce more practical examples of the loop. We are covering how to do while loop, if loop, and I hope later on you can use it to solve a practical problem. So I was testing a problem and it works. Let me try something else. Oops. Oh, okay. So I'm going to show you what I did, and it's actually quite interesting after we do that. So I can show you later on what's going on. So let's go through the PowerPoint first, and then we can take a look at what I want you to work on today. Okay, so in today's lecture, basically, we are going to get more familiar with while loop. So what's happening is you can do multiple things inside the while loop. Whenever the condition stays true, the loop will not stop. Okay? Sometimes you have some kind of logic. When this happens, you do this. When something happens, you do something else. So if you have a break inside the while loop, what happens is the break will jump out of the loop. So break helps you to stop. If there's no break, the loop continues when this condition becomes false. Otherwise, it will not stop. One way to stop it is to have a break inside the loop. Or the other way is, maybe during the process, you can change the condition to false. Then you will stop. Another situation is right here. You can say continue. When continue happens, it goes back to the first line, goes back to the beginning and start over. Okay? So break gets out of while, continue goes back to the first line of while. Okay, so let's try this. I will show you a different problem here. So I can say x equals to 1 while x is smaller than 10. I will print x, and then I will advance x by 1. So this is like a counter. If I show it on the screen, you will see 1, 2, 3, 4 until 10, right? And let's try to do something. During the process, if I add, if x equals to 5, I will break. What's gonna happen? You only see 1 to 4. Okay, so it was 1 when in the first time it prints out 1 and it will x advanced by 1 becoming 2. Is it equals to 5? No. So it doesn't go into the if loop. It goes back to the while and continue to do this until when x is already 4. So it prints out 4. The next line advance x by 1. So x now is 5. And it goes up to here. If x equals to 5, then jump in. it gets into the if loop and it sees break. So break breaks the while loop. So actually it comes out, finishes. Okay? So let's try a different thing. If I say if x equals to 5 here and continue. Let's see what's gonna happen. Okay, I should, let me see. Continue goes back to here for, I should say a smaller number, about 3. Okay. Sorry. I should, it never, so it doesn't break. How come? It's always 3. Okay, I should, let me see. What should I do? Something over here. How about this? I change to here. Okay, if I do this. So if there is no, or I say smaller than, when it's smaller than 3, we will print and continue. Oh, then it doesn't plus 1. Okay. Maybe I should try somewhere here. Okay. So I always add 1, but when it's smaller than 3, it will print and come to here. So when it's 4, it doesn't print and then continue. When it's 5, when it's 4, because it's larger than, so it will not print and continue to see this. Okay, so it should be okay. Yeah. So how come you only see 2 and 3? At the beginning it's 1. When it comes in, already add 1, so it's 2. So is 2 smaller than 3? Yes. So print out. Continue, so goes to the first line. So now it's already 2. Come up here, 3. Is it smaller or equals to 3? Yes. Print. Continue, go back to here. Come up, come down. Now it's 4. Is it smaller than 3? No. So it goes directly to here. So it's 4, but it's not 5. So it does nothing and comes to here. Now it's 5. So it doesn't do anything here, but it's 5, so it breaks. So it goes out. Okay? So when you design your logic, it will move around within your loop. If you didn't program this properly, sometimes you have infinite loop, like what I just had. It doesn't stop. How do you get out of the infinite loop? Use Control C. So I will write down right here. Use Control plus C to stop the code. If you jump into infinite loop. Okay? So later on, you can practice. Try to combine some while, some if. Try the continue and break. If you accidentally jump into infinite loop, use Control C in the command window. It will stop. Okay? So let me give you one small exercise and let's practice this. Maybe you can do show create a while loop starting from x equals to 1, okay? And every every time x will advance by 1, okay? And on the screen, print x every time, but if x divided by 3, so if you say 2 divided by 3, this is a remainder, 余数, right? So 3 divided by 3, it's 0. So whenever the remainder is 0, so if x divided by 3 equals to 0, then we do something, then we don't print. How about this? So you should be able to see 1, 2, 3, 4, but no 3, no 6, no 9. Okay? And keep doing the loop until x, or I say, and stops printing when after you see x equals, when you see 20. So you should see 1, 2, and then 4, 5, no 6, 7, 8. Keep on doing this until you don't see 18, you have 19, you have 20, and then stop. Try this. Okay? I'll give you the screen. So you need to think about how to achieve this. Start from 1. In the loop, every time advance x by 1. On the screen, I want you to print out x starting from 1. You should see 1, 2, 3, 4, 5. But during the loop, you use if when the remainder of x divided by 3 equals to 0, that means it's either 3 or 6 or 9 or 12. We don't print. We don't print out x. Okay, so keep doing this until when you see 20, then stop the whole thing. So you can try to have while, if, you can have break, continue. You need to think about how your logic is gonna look like. There are many ways to achieve this, so try different things. When you design a loop, you need to think about what you want to do, okay? I will build my while and if loop at the bottom. So if you have no idea what to do, you can look at the screen and see what I did, okay? You can follow me or you can try it by yourself. So over here I will use a different name. if you have no idea what to do, here's one example at the bottom. This is not the only way. Just one quick example. Okay? If you need help, you can take a look at mine. Not the only way. You can try your own way. Okay? I will give you 10 minutes to work on this. Did you have enough practice? Did you figure out what to do? So later on, we're going to do a very interesting exercise. I'm gonna teach you how to solve an engineering problem. I'm gonna show you how to do optimization later on. After today, you know how to do optimization by Python. Okay, so I hope you have enough practice and I hope you understand what to do. Let's go back to the PowerPoint, and I will finish my slide today, and then we can do the interesting exercise. There's another way to create a loop. It's called for. And how do you use for? So we already know while loop. And here you see something different. You see a variable plus equal and say 1. What does that mean? If you have, I already have x, right? If you say x plus equal and 1, that means x equals to x plus 1. Same as this line. Okay, so this is same as xx plus equal 1. You can also use plus equal. Okay? So sometimes if you program like this, people think you are more professional. You look more like a professional programmer, but in fact it's the same thing. Okay. In C, people use I think it's a plus, right? Is it? No, I forget. Is it x plus plus? Never mind. Is in the C programming. Anyway, x plus 1 means the variable plus 1. Okay, anyway. Now, what do you do for loop? So when we use loop, you usually have some kind of variable. And the value of the variable will change from within a range or within, you can say a vector. Okay? So let me show you what does that mean. If I have, say, something called y, and it's actually a list, a series of numbers, 1, 3, 7, 9, something like that. And if I say for a different number z in y, and then I'm gonna say print z. Okay? Hold on. Sorry. Comma. What's gonna happen? Or I say z plus 1. Okay? Today my brain is not functioning well. I keep on programming in a different language. Okay, if I do that, you will see 2, 4, 8, 10. So what happened is you can have some kind of vector here, z in some kind of vector, and start with a 4. So z becomes a kind of variable inside your loop. And it will keep on looping until the value of z go through the component inside the vector. So in the first time, when you say for z in y, at the beginning, in the first round, z equals to 1. And then you will do whatever you want to do right here, and then jump up, go back to the first line of the for loop, and then it will move on to the second component here, and do the same thing over and over again until z becomes the last one and then finish. So if you want to do the same thing for exact problem right here, what you can do is, I'm gonna use yy. I can say for, okay, I can still use z in, and now I'm going to use a variable called range. My brain is not functioning. So what does range do? Starts from an integer, starts to another integer. So I can say 1 and 20. Okay? If I do that, and if I say print z, you should see 1 to 20. Okay, sorry. What's happening about range is that it doesn't include the last one. So you have to say 21. It doesn't include the last one. So, okay, then you will see 20 here. Then what can you do in order to get rid of the ones that has a remainder of divided by 3 having a 0 remainder? You can do the same thing here. And in this case, I'm using z and printing z, right? So if I do that, you will see 1, 2, 4, 5, 7, 8. So this code does the same thing for this one. But from here, you can tell you only need 3 lines. And for while loop, you need to have 5 lines in the way I program. Okay? So the advantage of for is that you can define where you can properly define where you want what value you want for the z. You give some kind of vector or array for z. So the for loop will go through from the first component to the last one. But the disadvantage is for the for loop, usually you have some amount of component here. So when this is done, it finishes. For the while loop, you can continue to do something whenever the condition satisfied. So you can allow this this loop to run for a long time. Okay, so they have their own advantage, and you may use them in different situations. Okay, let's try to use the for loop. Okay, and over here I show you 2 kinds of example. Here I use a list as the component after in, or you can use a range to define the range for the z. You can try both. Okay, I will give you the screen. You can try it. But remember, if you use range, the last component, the number here is not counted. It doesn't include 21. So let's try this. Try the for loop. So we already learned three kinds of logic. While something is true, we will do something here. Okay? And this keeps on looping if the condition is always true. If something is true, then do something, or else if some other things is true, do some other things, or finally else, do something else. Right? So we have learned the while loop, or so-called the if-else loop. This is so-called if-else. If something happens, do this. Otherwise, do some other things. If you have multiple conditions, you can have else if. Right? This is what we learned last time. And today we will introduce for loop. And you usually need a variable, and you can say in some kind of vector, then do something with the variable. Usually, this is how you use it. So you will keep on doing this until the variable equals to the last component of the vector, then finishes. And of course, for the while loop, we just talk about continuous and break. Continuous, go back to the first line, break, gets out. Right? So this is what there are the three major kinds of loops for almost all kinds of programming language. C++, Python, MATLAB, Java, almost all kinds of language has these three kinds of loop logic. And they are usually utilized for different situations. For myself, in my own research, I use all of them. Usually when you have something you need to continue to do, to work on, but it only stops when the condition satisfies some certain situation, then I probably use while. And if I just want to do something, just one thing or very little things, but I have different kinds of logic to check, different kinds of conditions to check, I usually use the if-else. If this happens, do this, otherwise do that, something else. And usually this is done only once. For the for, I already know I need to do something for certain times, and every time something change a little bit, then I will use for loop. Okay? So I hope you will fully understand how to use them. And in the future, when you program by yourself, you need to make a decision. Do I use while, if, or for? Okay? In MATLAB, there is something called switch. I'm not sure if Python has switch. Let me see. Python switch. Yeah, Python also has switch. So, really? See, this person defined his own switch. There's a logic called switch. In Python, in different version, there's something called match. It's basically the same thing as switch. Switch is utilized less than others. So I'm not going to cover switch. Okay. Did you have enough practice? Let's go back to the PowerPoint. Okay. So I did show some example in my PowerPoint, but I'm not going to cover those today. Over here, I also show some exercise that I did last semester. So I'm not going to do those. I will directly go through the slide. I think I already covered everything. Yes, here's a comparison. If, while, and for. Okay? I want to move on to today's exercise directly. And I will give you more time to work on this. So before, this is the code I want you to work on. It's a real engineering problem. But over here, you need to learn something called define. Define will be introduced next time, but today I want you to quickly see how define can be used. Actually, define is a way to define your own function. So over here, I say define function having some input, and if you say return, whatever you work on will be returned as an output. That easy. Okay, so I don't think we need a PowerPoint slide for this. We just use the most simple way to define our own function. So I will show you what's happening over here, and then we can work on this. Let me see. I want you to maybe we will try a different. Let me try a different function, not the sign. The sign is not stable. How about sign? How about this? So I should sign times x1. Let's see. Okay. Minus 5. No, not good. Let me figure out a function. Maybe some exponential. I hope it doesn't explode. No, don't do this. Exponential is too extreme. Okay, let's try just a simple problem. Okay, this is easier. Okay. So I have a math function called y equals to. This is a function of what? Y equals to x minus 5 squared. I'm trying to solve this problem. I want to find the minimum point right here. So there is a method called Newton's method. I think it's a really good method for you to practice while loop. So I need to explain what's going on here. Let me show a dark. Okay. So this is not a math course, but we are solving a real problem. We need to know the math. So if you want to find a minimum point for a function, Newton's method said you can have your solution right here, but you will have to have some kind of guess. So your guess, xk needs to minus some value here. This is the first order derivative of f using xk to plug in, divided by the second order derivative, basically f double prime. If you do this, keep on doing this, you should be able to find the minimum point. Okay? So I will show you how I program this. So it looks a little complex. It also looks a little complex in Python. But if you can do this, then in your project you can do a lot of things. So we will work on this today. When we try to do this, there's an issue. How do you do derivative in Python? So I teach you one way to estimate the derivative right here. The method is called finite difference. I think you learned about this in calculus. You know, for the derivative, if you want to have the true definition of first order derivative, basically is the limit of some delta goes to 0, right? And then what's the value? The function of f, plug in x plus delta, minus f of x divided by delta, right? And the delta has to be super small. So this value will equals to the derivative. I'm not teaching calculus right now, but numerically you can estimate the derivative if you assign a small value. This value cannot be 0 because if it becomes 0, then it goes to infinity, blows up. So you can assign a very small number here and do this kind of math. You plug in your x, but the first one you have some increment of delta minus the original function value. How about second order derivative? Maybe in calculus your professor didn't teach you this, but this can be easily proved if you spend some time or just think about it. So I'm going to tell you what's the equation. F of x plus x, delta minus 2 times of the fx plus f of x minus delta divided by square of the delta. So basically this equation is done by finite difference twice. Just perform finite difference twice, you can get this. I'm going to show you how we can do this in Python. So let me use you may need to look at your screen. And then, you may not see the board. TA, can you take a picture of the board and post it on Moodle or Facebook so they can always check on this. Okay, thank you. Now, get back to, we're doing this. And let's get back to the problem. I will give you a lot of time to work on this. So, I will show you what has been done. Okay. In the process, I use 3 libraries. One is math. So I create a shorter name, M, for the math library. Where did I use it? I use the absolute value only. Actually, sometimes if you have a more complex function, you can use math. Okay? And I also use something called NumPy. So it's a Python library that allows you to do a lot of numerical calculation. Okay, and over here, where did I use it? I use so-called the line space, linear space. Actually, if I use something different, it's also okay. So x1 is an array of floating numbers. So it's a unique kind of variable. It's an array. It's a vector. So it's easier for me to plot the figure. How do I plot? there's a library called maybe matrix plot library. So it's like a matrix or maybe it's math or matrix plotting library. And there is a method called pyplot inside this library. We use the pyplot to plot our function like this. Okay? Now, what did I do? I created a cell-defined function, and over here, this is my function. So it's x minus 5 squared. And over here, I create something called d function. What is d function? Basically, derivative of the function. And right here, what did I do? I directly use the function I created. I can already use it. So it's the function value, and then over here I will have something called x plus delta minus function of x divided by delta. So since I need to define my delta, so delta will be my second input of this function. So you can have two inputs for this self-defined function. How about dd function? So basically second order derivative. So over here I perform the exact equation I show you on the screen. Function of x plus delta minus 2 times of the function plus function of the x minus delta divided by square of the delta. So if you do this, you can work on Newton's method. So over here, I'm going to show you how you can truly do Newton's method. So k is an index for me. I start with 0. And over here, I have an initial value. So I use the bracket, the squared bracket. So it's a list. I want a list. I don't want tuple because tuple doesn't allow you to modify. Okay, so I have a list. I will expand the list because I want to keep on finding. I will have 0.4 first, and then Newton's method will allow me to have new values. Okay? So over here, this is my x, my initial guess. I plug in the function. How do you plug in? Just say func and put the number here. So my xk basically is the 0.4. I plug in the function. I use a square bracket, so y is also a list. Okay? See, x is a list, y is also a list. So I can expand the list. Now I need delta, so I define a value here and a small value. And for for Newton's method, you usually use a while loop, and you will define some error. When the error is small, we stop. So that's why we initially have a large value, error equals to 100. When the error is larger than a very small number, this while loop will not stop. Okay? So inside the while loop, what do? You will compute a new x. So because it's a list, I use x append. So it will add one value to x. So what is the value I add? Basically the Newton's equation. Your original x divided by derivative of x divided by second order derivative of x. Just like what I showed you on the screen. Once I complete, I also want to compute what is my value of the function. So here I compute the function value of x at the k plus 1 component. Because I already append x, now the k plus 1 is the new x. I plug in, the function value will be added to y. So I append y. Now I have new x and new y. I will compare the new x, which is x of k plus 1, minus the original x. I compute its absolute difference. When the difference is large, I will continue. So Newton's method guarantee later on the error will be small. Then when it's small enough, we will stop. So when this is satisfied, when it's smaller than this, the loop will stop. But before you move back to the while loop, this k index will advance by 1. So your program right here doesn't need to change. You just allow the index to increase by 1. So when this while loop is done, you are supposed to getting the true solution. The bottom part is just to plot the result. What did I do? I create a vector from 0 to 7. This is like a linear space. So x1 is like a linear array. Let's take a look at x1. x1, 49 is 7. So I use the library NumPy to give me a vector, and by default it will generate 50 values, 50 of them. The size is 50 of them. So if you plot x1, it should print x1. Come on. You should see a bunch of values. It's a vector generated by this method from NumPy. It starts with the first input, ends with the last input. In between, there are totally 50 components, evenly distributed from 0 to 7. So this helps me to plot. So basically, I draw a curve of x minus 5 squared. Actually, they are 50 points. Let me see how you can show the dots. I forget. Let's see, where is it? Let's see. I plot. Okay. Okay. Maybe I change this to, I guess, circles. Yep. O means points, circular points. So they are actually 50 points. Sample from x equal to 0 to x equals to 7. And this one I will just print out. I think they can do this. Yeah, but can I do this? Yeah, okay. So, over here I have a vector of x1. It's a NumPy variable, NumPy vector. If you perform any math, NumPy allows you to compute for every component inside the vector. So you will see I have an array, a vector of 50 values. I just need to use one equation. It performs 50 times of this equation, starting from x equals to 1 until x equals to 7. So y1 also is a vector. Okay? So they are function values by plugging in x equals to 0, and then x equals to 0.1428, and then the other one. Plugging in multiple times, plugging into this equation. The result will be those. Okay? So now I have a vector of x1 and another vector of y1. I can plot the points. So over here, I am using this line. You just need to say pi plot dot using the method of plot. And then plot out put the vector here. I'm using the style of dot. So these dots are the functions I sampled. And I also plot out x. What is x? X and y are the solution that I found from Newton's method. I started from x equals to 0.4, so originally it's like an initial guess. Next, Newton's method said you should go to here, very close to 5. So Newton's method is very powerful. It will tell you where is the minimum point. Okay? So, this is today's exercise. Before I let you start to work on this, any questions? Any questions? You can just copy the whole thing. That's fine. But I want to use this as an example. I show you many new things. They are not very difficult. I use this practical case to show you how you can import math library, numeric pi, how do you do plotting, how do you do self-defined functions, how do you really solve a math problem like this, okay? When you do your project, you are really working on real math problems. So your program will be a little complex. This is the first time I show you a little complicated problem. Okay? Any questions, you can raise your hand. I can answer in Chinese if you need Chinese translation. Yeah, what's the question? Because this is the original function. 因为这是原始的函数嘛 and I want to plot the function. Same function. Over here, this is where I plug in. But every time you plug in, you only plug in one value. So you get one response. But over here, I use NumPy. This is just for me to plotting it. So x1 is a vector right here. x1 is a vector. So if you plug in y1 like this, y1 also a vector. So this is a special method for NumPy. Only NumPy allows you to do math with a vector. Okay? So if you don't have this, maybe one way to compute this function multiple times, you need a loop. Okay? So let me show you one example. If I want to compute y2, do the same thing y2, but if I don't have NumPy, usually what happens is you have to say for some index I in a range starting from 0 to, there are 50 of them, so 50. So actually I goes from 0 to 49. So that will be the index. And you will say y2, and then you have to use a pen. So you may have to say y2, the first one equals to, now you plug in. You do this, but you only have the first one. Something like this. And now you need to have your second one. If you don't have NumPy, you may need to say this, append. And whatever you compute will be like this. And over here you index I. And you already have 1, you have 0 outside, so here you use 1. Let me see what's 1. Hold on. Why Why? Let me see why. Why can we do this? Y2. Sorry. I should do this. Like this. Yeah. So the first one will be. So you are like plugging in the function one by one. If you don't have NumPy, you have to do something like this. Okay, so you are having a for loop, and then you advance the index one by one using a loop. So at the end, you can plot out the whole thing. You can do this, and this time I'm gonna use just straight line. Okay, and here is x2 and y2. No, x1 and y2. And I'm gonna show the plotting here. So if you do that, at the end, something is wrong. Pen, y2, pen. Sorry, this has to be a list. Otherwise, you cannot do a pen. Okay, so the green one came from this part. So if you did not use NumPy, this is more like a traditional way. You have to plug in the function 50 times using a for loop. Okay, so I will keep this here for your reference. Okay, I may need to let me see. I'm out of the screen, so I will. Change the font size. How do I change it? Setting. Where's the setting? 2. Okay. Yeah. So maybe 15. Too small. Okay. So if you want to take a picture, you can quickly take a picture now. Okay. Any other questions? Okay, I hope we didn't introduce many stuff today, only for loop. But in the example, I add a lot of new things. Learning Python is like this. There's always a new thing. And very easy to program, but you just need to know what to do. Now, I will give the screen to you. If you are done, you can go home. You're finished. You can leave. So I'll give the screen to you, and the TA will update what you need to work on the system. Okay. Whenever you're done, even if you copy this, that's fine.